Hi guys, today is the 27th of February 2023 and exactly 5 years ago on 27th February 2018 I have switched on my off-grid system the first time. This here is a lithium-polymer, a LiPo battery pack, 10 kilowatt hours or 200 amp hours when I got it. So it's a very simple system. I have a battery, I have an all-in-one inverter, and that's it. And this is running for 5 years now. 2 years ago, after 3 years, I made a video and we have opened this battery pack, and at that time we have tried to find out the remaining capacity on that pack. And after some months I have then also built a DIY battery monitor, which is since then monitoring over this system and counting cycles. After the first capacity test with the battery monitor, we found out that the capacity that at that time, after 3 years, was around 8,400 watt hours, and since then I run maybe 2 or 3 more tests in the meantime, and my last test was at 8,326, but that's already a long time ago. And today I want to make another capacity test. The cycles we are standing at the moment is 1,227. That's a very big number, because LiPo battery cells are not known so much for longevity. They are known for their performance, and also the seller has given me a warranty that time that the pack will maintain more than 80% of capacity, so a state of health of more than 80% after 500 cycles. So we have now more than double of this, so almost 3 times that cycles. And yeah, it will be interesting to know how this looks at the moment. The day is almost over. We will start the test at around 96% of charge, because that is the maximum voltage I can reach with this all-in-one inverter charger there. This pack was never charged up to 100%. This is a good thing when you want to maintain a good state of health. And usually I discharge this pack down to around 20%. And the battery monitor is then calculating the total capacity. Right, this is going automatic, and tomorrow in the morning we will just read the value on the display, and that's it. How does the normal discharge cycle look like? So I have a garden lighting here connected to this, and at the beginning there's a bit more load on there, because there's some signs and the pool lights, which will then turn off at some point. So for the first 4 hours the load will be around 500 watt constant, and then for the rest of the night it will be around 420 watts. And then in the morning we will just check how it looks like. Okay, so we have to set a few things here, and then we just start with the test. So this here is the battery pack. It was customs built by a Chinese company 5 years ago, and yeah, I have my must all-in-one inverter also operating since 5 years, with one downtime only, and my DIY battery monitor. So what we have to do is, I wanna disconnect the inverter from the grid so that there is no bypass switched at some point. And then we can disconnect the solar array now, the PV array, and this makes now sure that every bit of energy which is now going to the inverter really comes from the battery. So I am switching the monitor now to the discharge mode, and so we see the start value. The end will be shown then tomorrow and estimating capacity, and we will then see amp hours and watt hours of the pack. Okay, so now also the inverter, we don't have grid, we don't have a PV array, so all the power is coming now from the battery. So the 2.8 amps, the load which you can see at the moment here, this is coming from a Wi-Fi router and a chest freezer, which is also on this circuit. The test will be finished soon. So this is the load which is running on that system. So every light you see is part of the garden lighting and is powered by the inverter over the battery during the night. It's 8 o'clock in the morning. I think we have waited long enough. Let's see what happened during the night. So we are still discharging, of course. 116 amp hours, 6078 watt hours have been discharged, and we have discharged from 95% down to 20% state of charge, and the estimated capacity is 8104 watt hours. I'm gonna press my button here now, and this is saved. Switching back this PV array and my grid, and the system is reset again. Inverter will start charging. So 8100 watt hours left in that pack. It was originally 10,000 watt hours. 2 years ago the result was 8400, so the pack lost around 300 watt hours in 2 years. Now the state of health stands at 81% after 1230 cycles. That's a great result. So we are very much better than LiPo cells have been actually warranted at the beginning. LiPo was sold at the beginning as a affordable cell chemistry also in these residential packs. This is not done anymore, so nowadays every battery system which is meant to run at home will be a lithium iron phosphate. But as I said at the beginning, this was the only affordable solution. The result is showing clearly that after initial degradation, so the packs may lose maybe 10% of their capacity in the first year, the degradation will slow down and will be kind of a linear degradation over many years until probably one day the pack fails. So very good result here. What are the reasons I think that this pack is holding up so well? So first reason is I'm not charging the pack to 100%, so I'm not going into the final peak of the voltage curve, and I do not discharge this chemistry below 20%, because there you would have the typical drop of the voltage. So I'm in the middle part, and this keeps a lithium pack healthy. The second reason is running the pack on low C rates. So at charging, I still have a C rate of around 0.3. The maximum currents on this pack during the day, during charging, is around 45 amps. So with this capacity, that translates to around 0.3 C rate. But during the discharge, the C rate is way less than 0.1 C, and so the discharge is this pack, it's like a walk in the park, right? So absolutely very easy going. In solar applications, just always have a big enough pack and go easy on it, and this will also increase the longevity a lot. And the third reason are the environmental conditions here. So this pack is indoors and the temperature in that room is always between 25 and 30 degrees Celsius, and that's a nice area for lithium ion cell chemistries too, because the ions, the lithium ions, can flow easily between the anode and cathode. Yeah, so that was it. The next test we are going to make in another 2 years, or otherwise if there's anything happening with this system. It is very reliable, as I told you. The inverter is already now 5 years running without any problems, and yeah, the battery, as you see, keeps stable very well. Okay, so please comment on the down. What do you say about this? Would you have expected that this cell chemistry will perform so well? Please like, subscribe to the channel, and I see you next time.